Okay, guys, no questions there, hey? Right, I am moving down. Yes? Hey? Yes, I know. I'm gonna answer. Here we go. We're supposed to go to 50. Oh. Yeah. Yes. In front of a positive downward. Yeah, yeah, please. Okay, any questions on 24? 31? Down. Here you can see 27. And then the rest is on the next page. So I'll just give you guys a chance to mark all of that, then I'll turn the page. Okay, can I turn the page, guys? Okay, they are the next questions. And guys, in some of them, if they know brackets, they can just add subtract, right? If you don't have to still think about multiplying, it's only if you have brackets, like in 36. A positive times a negative is a negative, and then you just subtract. Now, guys, some of you were asking me questions yesterday, and I could pick up in the questions that you were asking that some of you are getting confused. All right, I need you to understand that when you have separate terms, right? So if I'm looking at this line, for example, -7 minus 9m. I'm not multiplying here, right? There are no multiplication symbols, there are no brackets. This is just a normal subtraction question. Like when you're saying 3 minus 2, you don't even think about multiplying this. Okay. So some people were asking me yesterday, quite a few of you. Now it's a negative and a negative, so is my answer positive? That's only when you multiply, okay, or when you divide it. So I can tell, and it's a normal thing, and I'm always grade 8, that people get confused. It's not just if you're seeing 2 minuses in the question, now your answer must be positive. It's if you're actually multiplying 2 negative numbers. In this case, we're not doing that, right? We're saying -7m. Now I must subtract another 9m. Okay, so the answer is going to be negative. Because from -7 to -9, you're going to -16. Okay, so just be aware of that, guys. Not a negative and a negative makes a positive. It's a negative multiplied by a negative. Okay, you have to be sure. Yes. Move it up. Yeah, I will now. Any questions on that page there now currently? All fine. All right, there we go. -1, yes. 46 is 2G. Right, any questions there? Yes. 42. Oh, it's still there at the bottom. No, I must move down top. Yes. Right. Okay, I'm going to move down, guys, so that you can see those last two, 42 and 50. There you go. Okay, guys, if you don't off, we're done with this chapter. Okay, we're moving on to something new today. We are moving on to fractions, yes. So you can make a new chapter immediately. Fractions. All right, guys, we are just going to do two sections today. We're going to work on some equivalent fractions, and then we're going to work on some mixed numbers, changing those to improper fractions. It is basically a revision of primary school stuff, just to make sure that we are all on the same page before we start the new work. All right, so there is a note on the classroom that I've printed out. Don't worry about copying any of this down. I just wanted to talk about what fractions actually are before we just jump into them. All right, usually fractions is a problem, if I can call it that, right? Lots of people don't like working with fractions. They find the word confusing. They forget the methods. Okay, so we're going to take it slow. We're going to make sure that everyone is on board. Okay. Yeah, they have just taken a circle, the same circle each time, and they have divided it up into parts. All right, so let me just actually read through this top. Up until now, we have mainly been using whole numbers and integers. In this note, we will tackle fractions. All right, so a fraction is a part of a whole number. All right, so like a half or a third or 2/5 or whatever. But guys, a fraction can also be bigger than a whole number, right? So a fraction can be something that's bigger than 1. I'm thinking of 3/2. Okay, 3/2. Do we know what number 3/2 is? Someone else? Yes? 1 and 1.5. Yes, 1 and 1/2, right? 3/2 is the same as 1.5. Okay. So some people say that fractions are numbers that are smaller than 1. That's not always the case. All right. You also get improper fractions. We are going to talk about that in more detail later on. So don't stress. So we can take one whole and divide it into equal parts. So that's just the diagram that they have here. So here we have a whole circle that could be represented as 1. Here we have taken the above whole circle and divided it into 2 equal halves. The green shaded, sorry, this one's supposed to be green, alright, but the gray shaded in this part is one part of the two halves. Alright, so if they ask you to write or to represent the shaded part of the fraction, you would say that this is 1 of 2, 1 over 2, right? Half of the circle is shaded. If we're looking at the next one, we can see that this circle has been split up into 3 parts, right? And one of those 3 parts is shaded. So we would write that as 1 over 3, 1/3. Okay, the next one. This is one part that's been shaded up 4 equal parts. Do we see that? I hope someone is not on their phone, is not a calculator. Okay, sorry, it looks like a phone. I'm just checking. All right, so that is 1 of 4 equal parts, so a quarter. But guys, what now if I shaded that part as one? Oh, lots of hands. They're at the back, yes. That is now 2 quarters, right? 2 over 4. But at the same time, you see that it's also a half of the circle. So it is actually also equal to 1 over 2. And guys, 2 over 4 and 1 over 2 are equivalent fractions. Equal fractions, all right? Because they actually mean the same thing. 2 of 4 is the same as 1 of 2. Can we think of another example that is equal to the same? David? 4 over 8. Yes. Another one? 3 over 6. 3 over 6. Yes. 16 over 32. All right. With the second class. Yes, Adam? 5 over 10. Yes. 6 over 12. Yes. 8 over 16. Yes. Yeah, I'm going to stop there now. We are not. Okay? You get the idea. Thank you. Thank you, everyone else for supporting you. So those are all equivalent fractions. Now guys, equivalent fractions, like the proper definition of equivalent fractions. I'm going to write here. Fractions that represent the same part of a whole. So like we saw now in that example, we could split the circle up into 4 parts, right? So if you have 2 of those 4 parts, that's actually the same as if we have 1 of 2 parts. Okay, so they represent the same part of a whole. But then the other thing about equivalent fractions is that when you simplify whatever the fraction is, right, or multiple fractions, they simplify to the same simplest fraction. We'll look at that now. So equivalent fractions simplify to the same simplest fraction. Okay, so the types of examples that they, let me just check here. Yeah, the types of examples that they can ask you when you're working with equivalent fractions, they can ask it in different ways, but they should look at one type of question. Examples. They complete the following equivalent fractions. We're just going to do a few of these. I'm just going to write my fractions over 2 lines so that it's clear, so that you can see what the values are. Right, I don't want anyone to shout this out, you guys. So there we go, 77 over 14 is equal to something over 2. All right, then we just do it fixed related. Now what you're going to do is they've given you the two denominators. So you need to figure out what is the relationship basically between these two denominators. What must you do to 14 to turn it into 2? Alex, divide by 7, right? 14 divided by 7 is going to give you 2. So just write divide by 7 in a different color or in pencil. Now guys, when you are changing something to an equivalent fraction, whatever you do at the bottom or at the top, you must do at the other part as well. Right, so if we're dividing the bottom, the denominator, by 7 to get 2, I have to do the same thing at the top. The top I also have to divide by 7. Okay, so the answer there is 7 divided by 7, Ryan? 11. So that is what you would have to call in here. Okay, so that means that 77 over 14 and 11 over 2 are equivalent fractions, right? They are equal to the same thing. Okay, one example, let's do another one. I'm going to write down a couple and I want you to do them on your own, all right? Don't shout them out, I'm just going to write them down. Yes. Right, that's the second one. I'm just going to write down 2 more. Don't shout it out, just do it on your own, please. I'll give you a minute or so just to do those quickly. Wait. Are you wanting to ask a question? Yes? Yes? Okay, let's take a look, guys. I'm just going to fill in the work in here and then I'll ask people to give the answers. So to go from 16 to 4, you need to divide by 4. So you have to do the same thing at the bottom. And guys, you don't have to write in that work. You don't feel like you need to, but I'm just going to do it so that everyone can see. All right, so 12 divided by 4, yes, Alex? 3. Okay, for number 3, 100 over 40, this was an easy one. You could just kind of skip. And just a proper like method, you would say, okay, to go from 40 to 4, you need to divide by 10. So you would have to do the same thing at the top, and 100 divided by 10 is this, 10. Now guys, is 10 over 4 the simplest answer there? Is that the simplest form of the fraction? No, right? So these ones aren't actually neither. But they will simplify to 5 over 2. Okay, let's just write that in pink or whatever other color you're using at the back of it. This is the simplest form. So guys, that's another thing that they can ask you. They can give you a fraction and they can just say, write this in its simplest form. All right? So then, in order to get the fraction to its simplest form, you need to look for the highest common factor. That's what we call it. Okay? The biggest number that will go into both of those. So if we're looking at 140, for example, the biggest number that divides into 140 is 20. Right? So you would divide 100 by 20, that is 5, and 40 divided by 20 is 2. Or if it was 10 over 4, what is the biggest number that divides into 10 and 4? 2, right? So then you would say 10 divided by 2 is 5, and 4 divided by 2 is 2. So let's actually write that on the side there. Now guys, I did actually say that you don't have to write that working, but sorry, I want to go back and just change that because I just remembered that you have to do this without a calculator. Right? You need to be able to find equivalent fractions and simplify these fractions without using a calculator. So you actually need to show the marker what you're dividing by. Okay, so please add that in now, please. Please. All right, you need to prove to me why so it's divided by 10 and you actually did it in your case. Turning it into a mixed number. So in grade 8 or in high school, actually, we don't mind if we leave it as an improper fraction. Okay, so guys, we are going to talk about that now. We are actually going to do some examples. I think in primary school, you have to always write your answers as mixed numbers. That's not a thing anymore. Okay, you can then answer times 2 all the way up to matric. There's nothing wrong with that. Unless the question says, write your answer as a mixed number. Sometimes it might. Okay, yes? Yeah, that's a question. Okay, let's do the last one quickly. So there we're starting with a fraction that has now actually turned into 12 over 36. But guys, you can go that way as well. Hey, to go from 36 to 6, we need to divide by 6. So we do the same thing as the 12, and 12 divided by 6 is 2. Is that the simplest form? I don't know. No, right? 1 over 3, thank you. Yes, yeah, I could have done that. Okay, times so what? Times yeah, perfect. Okay, guys, you're gonna have to do some of these types of questions for homework, all right? But let's just move on to proper versus improper fractions, and just do some things on that. Sorry, let me change the setting. Converting. Yes, I'm just writing converting fractions. Yeah. Okay, now guys, we are even going to write a note on converting improper fractions to mixed numbers because, like I said, you don't actually have to do that. All right, we are going to focus on when you get given a mixed number and you have to convert that to an improper fraction. Okay, so for example, let me just write an instruction here. Write the following. And this you must also be able to do without a calculator. All of this stuff, guys, no calculator. Write the following mixed numbers as improper fractions. Let's just first remember what is an improper fraction. Yes. Yes, thank you. The numerator is bigger than the denominator. So the number at the top is bigger than the number at the bottom. All right, let's just write that. And guys, I'm going to show you some mathematical terminology. There's a symbol as well. So we're going to say the numerator. And instead of writing is bigger than, I'm going to use the greater than symbol. Have you seen that before? Greater than. Numerator is greater than, bigger than denominator. If you don't know what that means, just make a little arrow there and write bigger than. Okay? Numerator is bigger than the denominator. So like 5 over 2 or 10 over 7 or whatever. All right. Any number at the top that's bigger than the number at the bottom. Okay, guys. Let's do some examples. Number 1. I'm sure you know how to do this. We're just going to practice a couple and then I'll give you a worksheet to work on. 3 and 2 over 7. Thank you. Maybe when I do it, it will answer your question. Okay, so guys, you always take the number in front because that's a whole, right? So the 3 here in front, going to multiply that by the denominator. Yes? So do a little thing there to show that your times are there. What is 3 times 7? 21. Then you're going to add the number that's at the top. All right, so once you've done your timesing, you are going to take that 21 and add 2 to it. No, you don't have to add this. So you're going to say 3 times 7 is 21, plus 2 is 23 over 7. So that one you don't really have to show proof that you did it in your head. Guys, the reason for that is it's practice on a calculator and it's not necessarily going to come out like that. Okay. So you do have to do this in your head, but you don't have to like prove it. Okay. But guys, the reason for why I'm multiplying the 3 by the 7 is because this is actually the same as 3 plus 2 over 7. Do you agree? 3 and 2 over 7 is the same as 3 plus 2 over 7. Now guys, I'm going to change that slightly. I'm going to write that as 1 plus 1 plus 1 plus 2 over 7. Do we still agree with that? Is that the same? Yes? Now guys, isn't 1 the same as 7 over 7? That's 1, hey? 7 divided by 7, any divided by itself is 1. So I'm changing this one, I'm just writing it differently. And you don't have to do this. Okay, I'm literally just explaining the method to you. So please don't ask me, man, do you have to write it like that? No, you're just going to write the answer. Okay, I'm just explaining. So 1, you can write as 7 over 7. 1, you can again write as 7 over 7. And then that third one, again as 7 over 7. And then plus that 2 over 7. And guys, next week we are going to do how to add and subtract fractions, but I assume that you know that when fractions have the same denominator, you can write them all over one denominator, right? Do we remember that? So we have now 4 fractions with a denominator of 7, so I can write all of them over 1 7. Is that correct? So we can do it like this. We can say that first 7 plus the second 7 plus the third 7 plus that 2 all over one denominator because they all have the same denominator. Right? You're not going to add the denominators together as well. Right? You just put all the same denominators as 1 and you add the numerators together. Now guys, what is 7 plus 7? 14 plus 7, 21. That's what we get when we say 3 times 7. Hey, because there are 3 of those 7s. Do you see? 7 plus 7 is 14 plus 7 is 61 plus 2 is 23. That's where the plus 2 comes from. Okay, so that is why that method works, guys. Because if there's a 3 in front, that actually means that you have 3 of these numbers, right? 3 7s. And then you have that 2 there that you also have to add. Okay, let's practice some more. I'm going to say again, please don't write this in a text or exam. We're just going to do this. Okay, I'm just trying to explain. I don't know if it was explained to you in primary school why that method works. Maybe they just showed it to you, but that is why the method actually works. Okay. Next one, let's do 2 and 1 over 9. So you're going to say 2 times 9, 18, plus 1, 19, over 9. Right, you take that same denominator that you had. Okay, last one, and then I'll give you some time to work on your own. Let's do 7 and 2 over 5. Okay, 7, the whole, times 5, the denominator, 7 times 5 is 35 plus 2, 37 over 5. Okay, are we all clear, guys? Now, I know most of you would have probably done this in primary school. Sorry if you're not feeling it bored, but we do just have to make sure that we are on board with last year's work before we do new work. Okay, so next week, we're going to use these in more difficult questions. Okay, so I'm going to hand out a worksheet now. So I'm not going to do the whole worksheet. I will tell you which questions when I'm done handing out. You can do the first one for all of question 1, but then I'll tell you that the second half of the page together. Okay, guys, now one, pick the right function, take the corner, say, what function that as an example. Guys, you need to get into the habit of when you see a question first, read the instructions before you just jump in, okay? So they've done the first one for you. You can see that that circle has been split up into 6 equal parts and 5 of those parts are shaded. So the answer is 5 over 6. In the next one, I have the feeling that that bottom one is shaded, but it's very faint. Okay, let's just pull that in. So that you need to identify how many parts are shaded. Clearly, that's 1 in this case. Okay, so the top has to be 1. But 1 out of how many? How many parts are there in total? 6. So that one is 1 over 6, and that's all you do, guys. You just circle the correct one. Let's see, are the other ones more clear? Here you can see it's the first one, right? At the bottom, it's the top 2 there. Thank you. I didn't want to. No, so much fun. Here we go. And they do have extras at the front office. All right, guys, so that's what you're doing for question 1. For question 2, listen up, please. I would like you to do all of them. Looks like a lot, but it's just putting in one number that equivalent fraction thing. You can answer it on the page. You can do it on the page. Guys, there's a little gap. You just pull the number in there. Question 3. I don't want you guys to do all of them in question 3. It's a shame. It's the same thing a million times. All right, so I just want you to do 1, 2. No, let me change that. I want you to do 10 to 20. And guys, my instruction is without a calculator. Right? I'm giving you the ones with slightly bigger numbers so that you can practice that. You are doing a test on the 9th of March. That whole test, I have said it before, but I'll say it again, is without a calculator. And you have to practice now doing all of this stuff without that. Yeah. And on everything that's back, I'll give you a more detailed break, so I'll expose it to the back now. Okay, guys, are we all clear on what we're doing? We can definitely finish it in 15 minutes of training. Okay, if you are done, yeah, 15 minutes. If you are done before then you can do something else. Okay, let's first finish that.